So we want to know if this is true. So basically, if we just think about plugging in different numbers for x, so like if we plug in 5 minus 3 divided by 5 minus 3 is 2 divided by 2 is 1. So this is true. Just kind of put a check mark there. If x, what's x not allowed to be though? There's only one number that x isn't allowed to be. Yeah, so a couple people are typing it to me privately. Thank you. So x isn't allowed to be 3. The reason x isn't allowed to be 3, oops, that pen is not working, is because if x equals 3, then this is 3 minus 3 over 3 minus 3, or 0 divided by 0. And we know we can't divide by 0. Part D wants you to create your own rational expression that's equal to 0. We're just going to skip that part. Anything divided by itself is equal to 0. And then for your excluded values, it's whatever makes your denominator equal to 0. So part C says, I apologize. Mr. Wonder says that when any fraction or number is multiplied by 1, the fraction stays the same. For example, he says the product below equals x divided by y. Is he correct? So on his paper or in the book, it looks like this. Z divided by z times x divided by y is equal to x minus y. Mommy, can you let Dino in? In just a minute. Please let him in. This is true. Can you let him in? Because z divided by z is equal to 1. So again, this is just like a little review of the number 1 and everything we can do with it. So multiplying by the number 1 stays the same. This one just looks funny because it's z divided by z. All right, so moving on to 11-3, it says use what you know about the number 1 to rewrite each expression below in equivalent simpler form. State any values of the variable that need to be excluded. So A, x squared divided by x squared. I'm just actually going to write all of these down and then we'll go over them. B is x over x times x. Right. So I'll share the book. That way you guys can copy them down at the same time. All right, so I'm just copying all of these down. What, Forrest? I will let him in right after I do this problem. Okay, so to simplify these, oh, I think I copied A. Did I copy A down wrong? No. Okay. X squared divided by x squared. We know anything divided by itself is just 1. So A is 1. As long as x doesn't equal 0. Because if x equals 0, then our denominator is 0. B, same idea. So we have x over x, which is 1, x over x, which is 1, and then times x minus 3, or x over 3, sorry. So this is just x over 3. 1 times x over 3 is just x over 3. Again, as long as x doesn't equal 0. X can equal 0 if you just look at the end, because 0 divided by 3 is fine. But when you're trying to find your excluded values, you have to go back to the original problem. And so what would make our denominator 0 there? So part C, x minus 2 divided by x minus 2. Again, this is a big 1 here. This whole thing goes away. So this is just x plus 5 divided by x minus 1. These x's do not cross out right here. So this does not equal 5 divided by -1 or -5. These x's only get to make a big 1 if the whole expression is equivalent on top and bottom. So for this problem, so this is our answer here, x plus 5 divided by x minus 1, as long as x doesn't equal 2. If x equals 2, then this denominator is 0. And as long as x doesn't equal 1. So x can't be 2 or 1 because those make our denominator 0. You can find your excluded values before you even start the problem. It's what would make your denominator 0. So here on part D, same thing, excluded values. We know x can't be 0 because if x is 0, our denominator is 0. And then we can kind of cross simplify here. This 9 on top and 9 on bottom go away. X on top, x on bottom go away. So this is just equal to 1. Or if you multiply straight across, this is 9x divided by 9x, which is 1. So you can either simplify at the beginning or at the end. It doesn't matter. Part E, h times k divided by h. So 1h in our numerator and the h in our denominator go away. So this is equal to hk as long as h doesn't equal 0, because that would make our denominator 0. F, same idea. M plus 6 and m plus 7 in our numerator, or sorry, 6 and 6 in our numerator and denominator cancel out. So this is equal to 2m minus 5 divided by 3m plus 1. As long as, and then our excluded values, we have to figure out what makes our denominator 0. So this part, m plus 6, we know m can't be -6, because if m is -6, if I plug it in here, I get -6 plus 6 is 0. For my other part here, I want to set my denominator equal to 0 and solve it. So I want to know what would make this parentheses equal to 0. And that's essentially what I did here. I just didn't show the work. So I wanted to say, okay, m plus 6 equals 0, so m can't be -6. So if I solve this, I get 3m equals -1, or m equals -1/3. So this tells us m can't be -1/3, because if I plug in -1/3 for m here, I'm going to get 0, and we're not allowed to divide by 0. Part G, 6 times n minus 2 squared divided by 3 times n minus 2. So we know n minus 2 squared is n minus 2 times n minus 2 divided by 3 times n minus 2. So n minus 2 in our numerator and 1 in our denominator go away. We know that 6 is divisible by 3, so this can become a 1 and the 6 can become a 2. So we end up with 2 times n minus 2. Our denominator is just 1, so we don't need to write our denominator. And this is as long as n doesn't equal 2. Second. So again, n can't be 2 because if I plug it in here, I get 0. I don't care if my numerator is 0. I only care if my denominator is 0. So same thing, part H. Again, we can find our excluded values first if we want, before we even simplify. You just set each part of your denominator equal to 0 and solve. So 4x equals 1, x equals 1/4. 3 equals 2x, or x equals 3/2. So in this problem, x can't be 1/4 and x can't be 3/2. And then simplifying, in our numerator, we have 3 minus 2x, and on our denominator, we have a 3 minus 2x. Those cross out. So this 4x minus 1 is left in our denominator with just a 1 in our numerator. Because remember, when these cross out, they're really making a big 1. Anything divided by itself is 1. So this is 1 divided by 4x minus 1. Any questions? If I'm going too fast, let me know. Like I said, I think most of this so far should be a review. But what's really important here is kind of going back to this one, x plus 5 divided by x minus 1. These x's do not get to cross out. The whole expression has to be the same in the numerator and denominator. Same thing like here. These m's don't get to cross out because this 2m minus 5 is one expression. You can think of it with parentheses around it if it helps you, that whole thing has to stay together, which we will see in this next problem a little bit better. So Mr. Wonder, again, so he tries to simplify 4x over x and 4 plus x over x. He thinks that since x divided by x is equal to 1, then 4x divided by x is equal to 4. Is he correct? Substitute 3 values of x into the original expression to justify your answer. So we want to know, is 4x divided by x equal to 4? That's what we're asking ourselves. Okay, so we need to plug in some numbers. So let's say if x equals 3. If x equals 3, then we have 4 times 3 over 3, or 12 over 3, which is 4. So it works there if x is 3. Let's do a negative number. If x equals -5, I'm just picking random numbers. So if x equals -5, I have 4 times -5 divided by -5, which is negative 20 divided by negative 5. Negatives cross out. 20 divided by 5 is 4. That works. We can also do it with a fraction. Should work for any number. So if x equals, let's just do 1/2, then we have 4 times 1/2 divided by 1/2. 4 times 1/2 in our numerator is 2 divided by 1/2, which is also 4. So yes, this works. We picked 3 different numbers. We thought it was true anyways, and we showed it was true for those 3 numbers. All right, part B. And again, this is true. Sorry, I should have said this. If x doesn't equal 0. Because if x equals 0, we're dividing by 0. But now what Mr. Wonder wants to know if 4 plus x divided by x is equal to 5. Is this simplification correct? Substitute 3 values of x to show your answer. All right, so let's just start with if x equals 1. So if x equals 1, we have 4 plus 1 divided by 1. So 5 divided by 1, which is 5. So yeah, it works when x is 1. Let's try 3 again. If x equals 3, we have 4 plus 3 divided by 3, which is 7 over 3, which doesn't equal 5. We can try negative 5 again. If x equals negative 5, we have 4 plus negative 5 divided by negative 5. Negative 1 divided by negative 5, positive 1/5, which also doesn't equal 5. So this is no, not true. That is not equal. 4 plus x, oh, sorry, I'll move my paper up. 4 plus x divided by x doesn't equal 5. It only equals 5 if x is equal to 1. So part C says compare your results from A and B. What can an expression be simplified can an expression be simplified in this manner? Explain. So it can only be simplified if it's multiplication. So because then we can make our big one. Because this is addition, this is just one term, one expression, I should say, on the numerator that can't be simplified. So 4 plus x divided by x is simplified. There's nothing else we can simplify there. And then part D says, which of these is rewritten correctly? Explain how you know. D has number 1, or little I, is x squared plus x plus 3 over x plus 3. It says goes to x squared. And number 2 is x plus 2 in parentheses times x plus 3 in parentheses divided by x plus 3. Does that go to x plus 2? So we want to know which one of these, or both of them, or none of them is correct. So what do you guys think? Which one or 2 are true? So is 1 true? Is 2 true? Are they both true? Are neither of them true? Which of those is simplified correctly? X squared plus x plus 3 divided by x plus 3. And number 2 is x plus 2 times x plus 3 divided by x plus 3. Does that simplify to x plus 2? So, oh, cool. Getting a few messages, so take a minute, look at those. So here on number 1, this is no, this is not true. You can't take this x plus 3 and this x plus 3 and cross them out. That doesn't work like that because this is one expression in our numerator. On number 2, we're allowed to because this is in parentheses together and then this is kind of by itself, which is like parentheses that we don't write. So this one is yes, it's true. That one works. So the difference in parts 1 and 2 is number 2 is already factored. So they wrote it in multiplication. So that's what we're going to need to do on 11-5. So part A is x squared plus 6x plus 9 divided by x squared minus 9. So we want to simplify, and then it says assume that the denominator is not equal to 0. So we don't need to just figure out what makes our denominator 0 here. We're just going to assume it is not 0. So again, we cannot cross off these x squareds. We cannot cross off these 9s. We have to rewrite this in factored form or in as a product. So we have to factor all of this. So x squared plus 6x plus 9. So I'm going to factor that part. I'm going to factor my numerator first. Hopefully you remember how to factor, or this will be a very difficult section. So x squared and 9. We have our diamond. So if you want to use a diamond or use the product of the diagonals, the same idea. This is 9x squared on top, 6x on bottom. You're asking yourself what two numbers multiply by 9 but have a sum of 6. So this would be 3x and 3x. And so getting the outsides of our box, x, x, 3, and 3. So our numerator can be rewritten as x plus 3 times x plus 3. So again, I just took my x squared plus 6x plus 9 and I factored it. Denominator can also be factored. So if you are using a box and diamond, you might not need to here. I'll remind you in a second, but I just want to point out, if you're using a box and diamond here, the bottom of your diamond would be 0 because there's no middle term. Bless you. So this is what we call a difference of squares. And if you don't remember that shortcut, fine. You can use your box and diamond. It would still be x squared negative 9, negative 9x squared. But your difference of squares here factors to x plus 3 times x minus 3. Because these sides of our diamonds would be 3 and negative 3. So here, x plus 3 in our numerator, x plus 3 in our denominator, cross out. So we end up with x plus 3 over x minus 3. This is simplified. You cannot simplify this any further. And you can, if you're wondering why this could be like -1, if you plug in 0, then yes, this simplifies to -1, but plug in any different number. If I plug in 5 plus 3 would be 8, divided by 5 minus 3 is 2, 8 divided by 2 is 4. So it can only be simplified if when you plug in numbers, you get the same thing every time, like we did up here. But like I said, if I plug in, so like if x equals 0, then I get 3 over -3 or -1. If x equals 5, I get 8 over 2, which is equal to 4. So you can already see those aren't the same thing just by plugging in two numbers, which tells you this cannot be simplified. All right, questions? Just a few more with factoring. So B is 2x squared minus x minus 10 divided by 3x squared plus 7x plus 2. So, same thing. We cannot cross out any x squareds, any x's. This 10 and 2 can't be simplified to 5, nothing like that. We have to rewrite this in factored form. So, I'm going to go ahead and start factoring here. So I'm going to factor my numerator first. It doesn't matter which one you do first. So I have 2x squared and -10. So if I'm using a diamond, the top part is -20x squared, which again, if you multiply your diagonals here, it's -20x squared. The bottom of my diamond would be -x. So you're looking for two numbers that multiply to -20, but add up to -1. So what two numbers have a product of -20, but a sum of -1? Anybody? All right, there's yes. A couple people, thank you. So yes, this is -5x and 4x.
What happened into my phone?
So then the outside of my box here, this would be x, 2x, -5, and 2. So the top part my numerator can be rewritten as x plus 2 times 2x minus 5. And then we also need to factor our denominator. So we have 3x squared and 2. So the top of my diamond is 6x squared, or that's the product of my diagonals there, with 7x on bottom. So my sides would just be 6x and 1x, or just x. All right, so I get 3x, x, 1, and 2. So this can be factored to 3x plus 1 times x plus 2. So we see that there's x plus 2 in our numerator and denominator. Those simplify by cross out, they make a big 1. They divide it out. So 2x minus 5 divided by 3x plus 1. So this 2x squared minus x minus 10 all divided by 3x squared plus 7x plus 2 simplifies to 2x minus 5 divided by 3x plus 1. So you have to factor to get those. And just kind of a heads up here, most of the time these problems are going to have a factor the same in our numerator and denominator. If not, then you possibly made a mistake. Not every single one, not everything can be simplified, but most likely the ones in your book where you're practicing, they should be able to be simplified. All right, part C, we have 28x squared minus x minus 15 divided by 28x squared minus x minus 15. So on this one, my numerator and denominator are the exact same. So these do get to just cross out. So this one on part C is equal to 1. We don't need to factor it, again, because the numerator and denominator were the exact same. And last one, x squared plus 4x divided by 2x plus 8. So on the numerator, we have x squared plus 4x. You do not need to make a box and diamond here. If you made a box and diamond, this bottom square would be a 0 because there's no constant here. So this one, we should be able to look at it. I expect you all to look at this and see that there's a greatest common factor of x. So we're going to factor out an x, and now you're basically doing the distributive property backwards, or dividing by x essentially. X times something gives me x squared, so that's an x. X times something here gives me a 4x, so that needs to be a 4. And then just check it. X times x is x squared. X times 4 is 4x. Same thing in our denominator. 2x plus 8 has a greatest common factor of 2. 2 divides into all of my terms here. So if I factor out a 2, basically you divide each term by 2. This just becomes x plus 4. 2 times x is 2x, 2 times 4 is 8. So same idea, my x plus 4's cross out, and this simplifies to x divided by 2. All right, any questions? If you have questions, please stick around. On your homework tonight, yes, you are doing some of this. So on your first homework problem, number 7, you have to factor. So if you don't remember how to factor and want to stick around, I can go over that with you. You also have some stuff on the compound interest, which that's the last thing we did in our notes before break. We took our test, yes, but the last thing we did in our notebook. So you will need to go back and look at that. I don't expect you to have those formulas memorized. You also have other review questions, Pascal's triangle, with the binomial expansion. You have the graphs using the zeros, the roots. That's stuff you worked on with Mrs. Morgan, where you set each factor equal to 0, and that's where you have a root. Then you have some trig. I do believe it is law of sines or cosines, just by looking at the problem, not reading it, and then more trig. So lots of review stuff in your homework tonight. If you have questions on them, please ask tomorrow, or send me an email, whatever, so that we can go over those. Otherwise, you are free to go, and I will see you tomorrow.